All right, fellow fact checkers, we've got a brand new sponsor, and I am excited to promote this product. It's Fox and Sons Coffee. Now, Fox and Sons Coffee is a family-owned and operated small business selling whole bean, organically roasted, amazingly good coffee. On their website, Steve, the company's founder, describes how his love of coffee started with special Saturdays with his dad when he was growing up. Steve wants to share his love of coffee with you and the entrepreneurial spirit with his sons. Check out the website, foxinsons.com, and take a look at their best offer: a monthly subscription for 3 bags of coffee with free shipping for $38.89. Also, Steve's been on the show. He's a friend of the show. He follows us on the morning after as well as here on Fact Check This Podcast. Steve is a great dude, great company to support. So go check out Fox and Sons Coffee and get your morning started off right with a bag of delicious Fox and Sons coffee. Let's start the show. This episode will be completely taken out of context. Welcome to the Fact Check This Podcast. All right, Fact Check This Podcast, and today I'm continuing my reading shit series. Today I'm going to be reading a thread of tweets instead of an article, but it covers some really interesting stuff, and I thought most people probably don't know this stuff, so why not? We're going to go through the whole thing. It's enlightening, let's put it that way. So this is going to be about copper and the copper sector, and it's going to link into the green energy and stuff like that. So here we go. A copper redux. I live near one of the largest copper mines. So this is from BF Randall Mining Adams. I haven't found anything that indicates this guy is not who he says he is. So we're going to go with on the assumption that it's all legit. I live near one of the largest copper mines on Earth, Kennecott, Utah Copper, KUC. I helped manage a smaller copper mine for 8 years. Observation: wind, solar, and battery proponents and ESG bean counters are completely out of touch with copper mining and production. Beautiful pictures that are attached along with this. There's some articles as well. I'll link the tweet at the end so you can find it and go check out all the different stuff that's linked in here. Civilization's very first metal was copper, eventually surpassed in importance by iron and steel. But with Edison and Tesla, world demand for copper became nearly infinite. Butte, Montana held the world's largest high-grade copper resources, and the whole world came to Butte to mine copper. Several lines of my family converged in Butte from as far away as Croatia, Cornwall, and North Carolina to mine copper. My grandparents met there during World War II. Grandpa was the son of the USN OTS School of Mines. My mother was born in Butte. I know a thing or two about it. The so-called energy transition is a copper monster. The resulting demand for copper far exceeds anything the world has ever seen before, even during the electrification heyday, 1870 onward. See the graphic. The need for copper will double between now and 2035. For instance, a 3 megawatt wind turbine contains up to 4.7 tons of copper. Onshore wind farms use approximately 7,766 pounds, or 3.88 tons of copper per megawatt. Offshore's wind farms use over 21,000 pounds per megawatt, 10.5 tons. And here's for those who aren't watching the video, there's a plate that shows onshore versus offshore, the amount of pounds, the total number of pounds of copper that are used for the different wind turbines. Since 2004, $177 billion has been invested in U.S. large-scale wind production. It's a lot of copper. Solar power systems use about 5.5 tons of copper per megawatt. Heat exchangers of solar plus wiring and cabling that transmit the electricity in the cells. 262 gigawatts of new solar installations between 2018 and 2027 in North America alone equals 1.9 billion pounds of copper. A lot of copper. But the new demand for copper is driven by far more than wind turbines. So let's walk through a high-level simplified explanation of what modern copper production requires. And there's also a link to another tweet put on a hospital gown because they're going under the scalpel. Here's the new and totally unnecessary interstate transmission system that's going to cost taxpayers billions for garbage power we don't need. And this maps out planned projects and transmission projects to put in a bunch of wind and solar power across the country. So copper mining starts with drilling. Drill runs on diesel fuel, and they burn a lot. So this is one of the things, and I'll get into it more as it wraps up. But like this is one of the things that the morons who push for renewable energy and wind and solar specifically, they ignore everything that goes into making this. They just think that because a wind turbine runs on wind and not burning oil or gas or natural gas or whatever, that it's more environmentally friendly. They just think that because a solar panel sits there and derives power from the sun, that it's somehow more environmentally friendly. They don't put any accounting into everything that goes into making this stuff. In copper mines, fleets of drills run in shifts, often 24/7. The drill requires tires, lubrication oil, grease, dust control systems, and sophisticated electronics maintenance, etc. Strip ratio means the number of waste rock benches that need to be drilled, blasted, loaded, hauled, and dumped compared to the number of ore benches the stripping will open up. Strip ratios vary widely from mine to mine and phase to phase. Strip can be as high as 15.5 to 1. That means what you're getting is for every 1 ton of actual ore, you're getting 15.5 tons of strip and waste. And that's the general way that all of this stuff is mined. Like coal mining is not strip mining per se. Let me scroll back up and show this picture again. So this is what strip mining looks like. They're digging away and just constantly taking out layer after layer after layer to get deeper and deeper into this mine where they're taking the minerals out of. That's not the way they do coal mining, right? Like coal mining, you go into the mine and they're finding the veins of coal and they're mining them out. Like it's much more efficient type of process, but they can't do that with these precious metals and stuff like this. And you should see the really interesting thing and the really, really kind of scary thing as well is like the tungsten mines and some of the other lithium mines, the way that they go about getting that stuff out. And there's a leaching process with like the water and stuff that they use to keep the equipment running while they're mining and digging and burrowing through all this stuff. It's insane. Like the waste that's created from these big like strip mines like this is fucking unreal, and the environmental damage that kind of stuff does. Like we're in coal mine country. Like this is coal country here where we live, and they're mining, they blast, they dig, they extract, and when the mine is finished and closed, they fill it back in. So they backfill the whole thing. We have a number of fields out here to the north and to the east of us that are old mines that have been backfilled and then completely leveled off and cleaned up, and you would never know that there was a mine there. Now they're soybean fields and cornfields, and one of them has chicken barns on it, another one has hog barns on it. Like it's all been turned back into agricultural practical use. These lithium and copper, tungsten, like the different minerals and metals and stuff that are being used to make the solar plants and to make the windmills. Once this is done, this is now barren. This cannot be used. They might backfill it with some of the stuff that they've stripped out, but it's functionally useless. Like this is now barren ground. You're not turning this isn't going to get converted back into a cornfield. So continuing on, the strip ratio at volcanic massive sulfide deposits like KUC, the biggest mine that he was talking about earlier, are usually above 5 to 1. That means lots of tungsten oxide drill bits. The life cycle assessment for tungsten oxide production is not pretty. It's mostly made in China, which is home of hundreds of coal power plants. Larger patterns usually work for waste, but ore needs crushing. So drill patterns are tighter. Regardless, copper mining means drilling lots of holes through hard rock, and it can take weeks or months to drill out a single bench, a defined block in the pit. And there's a link to information on blasting, drilling, that kind of stuff, the whole process here. So I highly recommend checking that out. I'm not reading through that part as well. Like I said, there's a whole lot of extra information in here that really kind of rounds all of this out. And I'm just trying to give the 10,000 foot view of what's going on here. Then comes the fun part, blasting. Ammonium nitrate, fuel oil, ANFO, is the primary blasting agent. It's 94% ammonium nitrate with diesel fuel oil. AN is manufactured from methane and requires a great deal of fossil fuel energy and associated emissions. It is not coincidental that the Nobel Prize carries the name. Alfred Nobel's weird trick, dynamite, altered the course of humanity in countless ways, from war to the petrochemical industry to mining. After blasting, all shot material, waste or ore, has to be loaded into haul trucks and moved out of the pit. Waste is dumped, ore is loaded into the crusher. It's impossible to quantify the net fossil fuel resources consumed up to this step. The scale is enormous. And for those who are watching, like if you look at the equipment in the picture here, what you have to consider is that truck that's shown on the left is, I'm trying to remember the exact height. I think they're 40 foot tall and almost as wide or wider. These things are massive. Think about the amount and they're run on diesel. Think about the amount of diesel it takes to power one of those things. Think of the size of your own truck, your own car. Like my truck's about 6.5 feet tall and 12 feet long, 10 feet long, something like that. This thing is 40 plus feet tall, probably 80 feet long and 50 to 60 feet wide. Fucking nuts. Anyway, each tire weighs 12,000 pounds and is made with nearly 100% petrochemical feedstocks, hundreds of ingredients, and 100% fossil energy. Black equals a carbon black. Tires are not recyclable, and they don't last that long. KUC has its own tire landfill. The tires cost $50,000 a piece. There you go. Steel to manufacture the equipment, tires, lubricating oil, grease, fuel, maintenance, batteries, wear steel, moving things around the world, importing trucks from Korea, mobilization and demobilization, 100% consumptive just to drill, blast, pick up, and move rock. Ore has to be crushed. The scale of the equipment is hard to describe. The fossil fuel and other inputs that went into this single crusher in one copper mine and associated CO2 and other impacts, much less than the power to run it, are enormous. They have to have constant maintenance and replacement. A childhood friend of mine has been a KUC equipment operator for decades. These trucks consume some 92 gallons of diesel every hour. 92 gallons of diesel per hour. Whether they're moving or not. Sitting still idling, still burning through 92 gallons per hour. And the KUC fleet is running 24/7, 365. They never stop drilling. They never stop moving. Next, milling and grinding. Sulfide ore is hard and must be milled down to a fine sand. Each ball or sag mill is rated in thousands of horsepower. A single ball mill is 16,000 horsepower. You can't mill ore with weather power. Mills operate 24/7, 365. We aren't even close to being done. After milling and grinding, the ore must be concentrated and tailings floated. At KUC, this requires pumping millions of gallons of water slurry many miles, requiring enormous quantities of dependable electrical energy, coal and gas. Tailings are concentrator waste. The KUC tailings pond is enormous. Its construction to date has required moving billions of tons of rock, soil, clay, and engineered cover, tens of millions of tons of processed, washed, and screened and imported sand and gravel. Oops, sorry. It would be impossible to accurately quantify today the true fossil fuel requirements associated just with this one impoundment, its construction, maintenance, and reclamation. We won't know for years yet if its final size and configuration. Reclamation is decades in the future. Concentrates, 24% Cu, are smelted using coal. No other fuel will do. So in order to get all of the copper that's needed for all of these impressive wind turbines and solar farms, they have to use 100% coal to smelt for smelting purposes. So they're not decreasing coal usage in any way by doing this. Sulfide ore is high in sulfur, making KUC an important sulfuric acid producer. Acid is sold for mining other acid-soluble copper and uranium, making phosphate fertilizer and other processes. The ore at KUC is sulfide, not acid-soluble, but the ore at the mine I help manage is heap leached very efficiently using KUC acid derived from sulfide ore. Industrial operations are efficient and symbiotic. So what one mine makes, another mine can use for some of their processes. A lot of different ways that they go about doing this stuff. During smelting, the concentrates turn into lava and self-separate based on elemental specific gravity. Silica sand and other fluxing materials form a froth at the top and are tapped and removed to form slag. Metal values from the smelter are then removed. We still have a ways to go. Purification and separation of smelted metals and other valuable byproducts requires many more steps. Volumes have been written about KUC, one of the world's most important mineral sources. This thread is an extreme oversimplification. For copper, the process is electrowinning. Metal values are dissolved in H2SO4 and then plated out in the form of cathode plates. This step consumes vast quantities of electrical energy. To be sure, because it is cheap, EW plants often utilize wind solar power for load shedding. The fact that mining companies use load shedding agreements to soak up excess garbage power is not a compliment. It's because the value of wind and solar to the grid is so low that utilities have to pay to get rid of it. So wind and solar are providing so little value to the energy market that they don't really have a use for it. So they're actually paying to get rid of it, paying people to take that energy from them. And so that's the reason that they use it for certain processes that are a more low energy cost. It allows them to get their power for a cheaper rate and to be more efficient in the way that they do certain things. The wind and solar is the garbage fuel that they're using to run some of the simple basic processes that they need. The end result of the entire mining process is new cathode copper. I directly challenged analysts calculating life cycle impacts of wind solar batteries to account for the fossil fuel and carbon impacts expended in producing new cathode copper. It is 100% consumptive. Only the best and highest quality copper cathode meets the specs for generators like those used in wind turbines. The wire must be rolled thin and long, and any imperfections in the cathode result in broken wires. Turning a cathode into wires requires yet more fossil energy. Cathode is shipped from the mine to a rod mill, sometimes thousands of miles, including interim warehousing. At the rod mill, it's smelted in an electric arc furnace with dispatchable power. It can't run on EAF. You can't run an EAF on solar. And that's just the copper. If you take a look at the petroleum realities, it's not smart. So there's a lot. Like whenever they are, oh, here we go. It keeps going. 99% purity on virgin cathode is prized by rod mill buyers. Wire gauge governs resistance and other technical factors involving all generators. The thinner the wire, the more energy required, and the higher the purity of the feet, which limited high quality scrap can be used. Copper ore and grades. Copper resources have driven humanity since prehistoric times, especially Iberia and Cornwall. Advanced Roman metallurgy allowed them to flourish. I feel like I already read through a lot of this. Since Roman times, copper ore grades have been decreasing astronomically. So since Edison's and Tesla's inventions electrified the planet, this is a function of the natural occurrence of copper in Earth's crust and the cost of extracting it. There's another one of the mines for those who are watching the video. I highly recommend checking this out. Check this thread out. There's a whole bunch of information on it. There's a whole bunch of other stuff. I'm not going to go through all the rest of this. I think I've pretty thoroughly covered most of what I wanted to get out of this article. One of the things I did want to kind of talk about a little bit more to sort of wrap it up is when we're looking at all of the push for renewable energy, the thing that they don't talk about is everything that these solar plants, the solar panels, the wind turbines, like they don't talk about the things that they're made out of. They don't talk about what's actually going into this thing and the environmental impact or consequence of making that stuff. I mean, that was just looking at copper itself. You know, when you're talking about the trucks, you're talking about the amount of mining, the strip mining, the way they do it. You're talking about all of the processing power that's required just to get that product turned into something that's usable so that they can make this stuff. And like I said, that's just the copper. That's not any of the other components. None of this stuff is being made from normal steel that you get, you know, steel or iron from the regular steel mills, which also, you know, they generate a lot of there's a high energy cost on those to run those kinds of things as well. But like, because they are a lot of specialty metals and a lot of specialty parts that go into these things, like the manufacturing just to get the pieces required for this stuff is outrageous. And then solar panels, you know, you get a hailstorm and now you lose functionality on significant amount of them. The windmills, whenever, like when you see a windmill farm, think about moving parts. So this thing is constantly spinning 100% of the time. There is a motor, there are bearings, there are gearboxes, there are all kinds of different moving parts that are attached with just the fact that this thing spins 24/7, 365, non-stop. It doesn't do that without oil and grease. Bearings don't turn without grease. Gearboxes don't run without oil. None of this stuff works without those basic things. And they are enormous. And they also require constant maintenance, which they don't get because they can't pay enough people enough money to monitor and service these things all the time, because you would have to be monitoring and servicing them all the time. General bearings and gearboxes should be checked and serviced every 100 to 120 hours of runtime. So these run 24/7 every day of the year. That means every single windmill needs to have its gearboxes and all of its bearings serviced weekly, at least. They're not doing that. That's not happening. Nobody's out there. And so what you also start to see with these windmills especially is there's a huge amount of oil that just starts leaking out of them. And basically once they break, like they don't service them, they don't work on them, they don't fix them. So once they break, they're just effectively dead. Either the whole prop falls off of it and hits the ground, and then you've got to deal with the damage and everything else that does, or it just stops spinning and won't ever spin again, and then it's functionally useless. Plus it's taking up a huge amount of space. Like the footprint on these things is not small, especially if you stack them all together. Like if you were to put the number of windmills or the number of solar panels required to get even remotely close to the same output of a natural gas or a coal power plant, the footprint would be unheard of. Like how much nature is being destroyed, is being taken away just to house these things. There's also leaching and runoff that comes from finished solar panels. They create waste. They're not completely clean energy. Like none of this stuff is actually like clean energy. They generate waste, and that stuff is fucking toxic. And once it's leached into the ground, it's functionally useless. Like I was talking about with these these coal mines. Like once they get done mining, they'll backfill the mine, and then they'll turn it into a field. You can't do that when these solar panels are all dead and don't work anymore. You can't strip them out and then just till all the soil up and go back to farming. The chemicals and the shit that is leached out of this have now made this poison. This is now toxic. This now is not functional for anything other than a fucking landfill, basically. So that's green energy in a nutshell. Saving the planet by speeding up the rate at which we destroy the planet. Congratulations. We are going to see the end of the world, and it's going to be thanks to the environmentalists. Lord, bring the day. Hope you have a great rest of your day or a great rest of your week. I'll be back with another episode. I don't know, whatever day it comes out, Monday or Wednesday. Not sure when this one will drop. Hopefully you got something out of this. I highly recommend you go and look into all of this stuff. Look at the lithium mining. Look at the tungsten mining. Look at more into the copper mining. Like look at the components and the parts and the pieces that go into solar panels and wind turbines. It is fucking outrageous what is going into it, and it's even more outrageous what they have to do to get that stuff to make it. And of course, none of the people who have a problem with destroying the planet have a problem with, cell phones or any of the other, their electric cars, the batteries that are running their electric cars. Holy fucking fuck. You want to talk about like expensive parts and components and shit that is destroying the planet in order for them to make it. Look into what's going into making batteries for electric cars. Like it's the most illogical, hypocritical crock of shit you will ever find. That is green energy at its core. Destroying the planet as fast as possible while pretending you're saving. Some typical leftist bullshit. I'll catch you on the next one. Hopefully it'll be good too. Later. Don't forget to head over to PalomaVerdeCBD.com and check out our longest and most favorite sponsor, Carlos and Vanessa Abelar and Paloma Verde CBD. Get all of your CBD needs, and you get 10% off your order of $75 or more, plus anything over $75 is free shipping. So head over to PalomaVerdeCBD.com to get all your CBD needs. Have a good week, everybody.